This is the first video in Unit 10 for Accelerated Geometry. Unit 10 is on polynomials. In sections 10.1 and 10.2, it's on polynomials and multiplying polynomials. Key vocabulary is monomial, polynomial, degree of a monomial, degree of a polynomial, leading coefficient, binomial, trinomial, and polynomial function. By the end of this video, you should be able to answer the question of how do you evaluate, add, subtract, multiply, classify, and graph polynomials. A monomial is a number or a product of numbers and variables with whole number exponents. A polynomial is a monomial or a sum or difference of monomials. Each monomial is a polynomial, or each monomial in the polynomial is what we call a term. Polynomials have no variables and denominators or exponents, no roots or absolute values of variables, and all variables have whole number exponents. So some examples of polynomials would be something like x to the fourth, or 2x to the fifth plus 5. Things that we would consider not polynomials based on these rules is we can't have negative exponents, you can't have variables as exponents, you can't have variables as the denominator, your exponents have to be whole numbers, there are no absolute values, there are no radicals, and even if you had something with the decimal instead of a fraction here, that's still not a whole number. So x to the 0.75 would also not be a polynomial. The degree of a monomial is the sum of the exponents of the variables. So example 1 says identify the degree of each monomial. So in this case, we only have one variable, so the degree of it would be the degree of the monomial. So in this case, it's 3. If you have a number with no variable, you kind of have to think of it as though it's really the variable raised to the 0. So the degree here would be 0, because anything to the 0th power is 1, so that's the same thing as saying 7 times 1, which is just 7. C, you have two variables here. So it says that the degree of the monomial is the sum of the exponents. So we would have 3 plus 2, which in this case would be 5. And on D, you have a 6. B is really being raised to the first, and C is raised to the second. So 6 plus 1 plus 2 would give me 9. A degree of a polynomial is given by the term with the greatest degree. A polynomial with one variable is in standard form when its terms are written in descending order by degree. So in standard form, the degree of the first term indicates the degree of the polynomial, and the leading coefficient is the coefficient of the first term. So what is this really saying? If you have this polynomial, if you notice, it goes x cubed, then x squared, x to the first, x to the 0. So it's in order descending by the degree of the exponents. Your degree of your polynomial is the degree, the highest, basically the highest exponent here. Your leading coefficient is the coefficient in front of whatever has the degree of the polynomial. A polynomial can be classified by the number of terms. A polynomial with 2 terms is called a binomial, and a polynomial with 3 terms is called a trinomial. A polynomial can also be classified by its degree. So this is something that you're going to want to memorize, that if you have a degree of 0, then it's just a constant. A degree of 1 is linear. A degree of 2 is quadratic. A degree of 3 is cubic. A degree of 4 is quartic. And a degree of 5 is quintic. Example 2 says to rewrite each polynomial in standard form, then identify the leading coefficient, degree, number of terms. and also to name the polynomial. So I'm going to look for the highest exponent. In this case is x squared. So that's going to be my first term. So the standard form is going to be 4x squared. The next highest is x to the first, and then our constant. So our leading coefficient is the number that it starts with. So this is a 4. Our degree is that highest exponent. So in this case is 2. Number of terms, well, how many terms are there? There's 1, 2, 3. So naming it, you're going to name it by the number of terms, and you're going to name it by the degree. So based on the number of terms, it's a trinomial because there's 3 terms. Based on the degree, a degree of 2 is a quadratic. Now, it sounds kind of funny to call it a trinomial quadratic. So typically, what you will see written is a quadratic trinomial. But the main thing is that you have both parts. For part B, for standard form, look at your degrees. You have a 2, a 3, a 0, and a 1. So your highest degree here is of the cube, so it's going to start with x cubed. Then we have the x squared. Then we have our 2x and our constant of 5, or negative 5. So our leading coefficient, what's really in front of this x to the third, is a 1. Our degree is 3. Number of terms, there's 1, 2, 3, 4 terms. So our name, a degree of 3 makes it a cubic. And number of terms with 4, it's above 3, so we only have the names of a monomial, binomial, and trinomial. So anything above the 3 for the number of terms, you're just going to write polynomial. And then state how many terms there are. So in this case, with 4 terms. Example 3 says to add or subtract and write your answer in standard form. So what I'm going to do here is some of you will just use the horizontal method, which is basically for addition, you would just collect like terms. But I'm also going to show you the vertical method that for some of you, the organization will help you a lot. What you want to do is make sure they're in standard form. So in this first one is in standard form. You start with a square, then a 1, then a 0. So I'm just going to rewrite that. The second one is not in standard form, so if I rewrite this in standard form, that would actually be 16x to the third, the 6x squared, and then the minus 5. So I'm going to put the cube out front here because there isn't a cube in the first one. Then I have my 6x squared, so I'm going to line it up with the x squared. And then I have the constant of 5 that I'm going to put underneath the 11. And we're adding these, so negative 11 and negative 5 makes negative 16. 6x and 0x really makes 6x. Negative 36x squared plus 6x squared is going to give me negative 30x squared. And then you have your 16x to the third. So the answer to this problem would be 16x to the third minus 30x squared plus 6x minus 16. For subtraction, for some of you, you distribute the negative and then collect like terms, and that's fine, but I'm also going to show you another way of doing this. So first thing I'm going to do is put this first one in standard form. So I have 5x to the third plus 6x squared. There is no x, so I'm going to leave a blank here, and then we have a plus 12. Then we're subtracting. The 15x squared is going to go underneath the x squared here. The 3x will go in the place where the x would have been, and then we have the minus 2. So 12 minus negative 2 really makes 12 plus 2, which gives me 14. 0 minus 3 gives me negative 3. 6 minus 15 gives me negative 9x squared. And 5 minus 0 leaves me with positive 5. So my answer to this problem would be 5x to the third minus 9x squared minus 3x plus 14. Example 4 says the cost of manufacturing a certain product can be approximated by the function f of x equals 3x to the third minus 18x plus 45, where x is the number of units of the product in hundreds. Evaluate f of 0 and f of 200 and describe what the values represent. So for f of 0, we're literally just going to plug 0 in. So this is going to be 0 minus 0 plus 45 is just going to give me 45. So what that is saying is that f of 0 equals 45 represents the cost, the initial cost, because you haven't sold anything, before manufacturing any products. And then we're going to do f of 200 the same way. So I'm going to plug in 200. So when I plug in 200 and I type this in my calculator, I'm going to get that f of 200 equals this really big number. So what is this representing? So f of 200 represents the cost of manufacturing 20,000 units of products. Now, why did I say 20,000 instead of 200? Because if you go back to the problem, it says x is the number of units of products in hundreds. So 200 is really 20,000. Example 5 says to graph each polynomial function on the calculator, describe the graph, and identify the number of real zeros. So what you're going to do is you're going to go to y equals, and you're going to type in this function exactly like you see it, and then go to your graph. And when you do, you should see something that looks like this. Okay, so once you have it graphed, what you're going to do as far as the description, I just want to know, is it increasing, decreasing, or is it increasing or decreasing? So when we read a graph, we always read it left to right. So if we look at this graph and we're reading it left to right, and that means we go up, then we go down, and then we go back up. So on this first one, what we would write is that it increases, it decreases, and then it increases again. And then as far as identifying the number of real zeros, look and see how many times you physically see it cross the x-axis. In this case, it crosses the x-axis here, here, and here. So that's 3 times. So we can say that there are 3 real zeros. For B, if you type in your calculator under y equals 3x squared minus 2x plus 2, you will get a graph that looks like this. So as far as the description of the graph, what is it doing as you read it left to right? We go down and then we go back up. So we can say it decreases and then increases. And if we look at this, it never crosses the x-axis, therefore there are no real zeros. Example 6 says to find the product, which means multiply. So in part A, we have a monomial times a binomial, so we're just going to distribute here. So 4y squared times y squared gives me 4y to the fourth. Remember, you add exponents when you multiply. And 4y squared times 3 gives me 12y squared. For B, kind of the same thing, except now it's a monomial times a trinomial. So we're going to multiply the first So 3 times 4 is 12. C times c squared is c to the third. D squared times d is d to the third. Then the second one, that's going to be negative 18, c squared, d to the third. And then to the last one, 3 times 14 is 42. And c times c is c squared, and d squared times d squared is d to the fourth. For c, we have a trinomial times a trinomial. So what I like to do is the vertical method when multiplying something other than a binomial or a monomial. So in this case, make sure they're in standard form, and they are. So I have x squared minus 4x plus 1 times x squared plus 5x minus 2. And just like you would do the old time when you used to do like 24 times 14 by hand, you did the 4 times the 4, the 4 times the 2, the 1 times the 4, and the 1 times 2. That's the same thing that you're going to do here. So negative 2 times 1 is negative 2. Negative 2 times negative 4x is positive 8x. Negative 2 times x squared is going to give me negative 2x squared. Then we're going to do the 5x. So 5x times 1 is 5x. It's a positive. 5x times negative 4 is negative 20x squared. And then 5x times x squared would give me 5x to the third. And then we're going to do our x squared. So x squared times 1 is x squared. X squared times negative 4x is negative 4x to the third. And x squared times x squared is x to the fourth. And then we're going to add all this up. So we have x to the fourth. 5 minus 4 is going to give me positive 1x to the third. Negative 2, negative 20, and positive 1 is going to give me negative 21x squared. 8 and 5 will give me 13x. And then we have our negative 2. So our final answer is this right here. Let's try another. This first one's in standard form. The second one is not in standard form. So, and when I have a smaller one times a bigger one, I typically will put the bigger one up top. So that's going to be a squared minus 5a plus 2 in standard form times a minus 3. So I'm going to start with the negative 3. Negative 3 times 2 is negative 6. Negative 3 times negative 5a is positive 15a. Negative 3 times a squared is negative 3a squared. Then if I do my a times 2 is 2a. That's going to give me negative 5a squared and positive a to the third. So if I add them together, the answer would be a to the third. It's going to be negative 8a squared plus 17a minus 6. Last one, we have 3x plus 1 raised to the third. So that's really saying 3x plus 1 times 3x plus 1 times 3x plus 1. So I'm just going to FOIL these first two together. So that's going to give me 9x squared plus 6x plus 1. And then from here, I'm going to set it up vertically. So I'm going to do the 1 first. So 1 times 1 is 1. That's going to be positive 6x and 9x squared. Then if I do the 3x, That's going to give me 3x, 18x squared, and 27x to the third. So then if I add these two together, that's going to give me 27x to the third plus 27x squared plus 9x plus 1. And this would be your final answer. Last example. It says a standard box is p feet by 3 p feet by 4 feet p feet. The large box has 1.5 feet added in each dimension. And then it says, write the polynomial VOP in standard form that can be used to find the volume of the large box. So first, we know that the volume for a box is just length times width times height. So the length of the large box would be the small, which is p, plus 1.5. The width of the large box would be the width of the small plus 1.5. And the height would be the height of the small plus 1.5. And so now we're going to multiply all this out. So what I want you to do is to pause the video and try this one for yourself. So to begin, you should end up FOILing the first two together, which would give you the 3p squared plus 6p plus 2.25, and then you have to multiply that by the 4p plus 1.5. So if you set it up vertically and multiply everything through, your final answer should be 12p to the third plus 28.5p squared plus 18p plus 3.375.